There is a brown bottle sitting in your medicine cabinet right now. You paid $1.50 for it, maybe $2, at the drugstore on the corner. You bought it to clean a cut on your finger or disinfect a scrape on your kid's knee, and it has been sitting there ever since, completely forgotten, slowly losing pressure every time you open the cabinet door. What I am about to tell you will change the way you look at that bottle forever. Because that $1.50 that you have been ignoring for years is the single most powerful and most suppressed gardening tool in existence. And the people who run the $12 billion lawn and garden industry in this country have spent decades making sure you never figure that out. I have been growing plants for 25 years. I have tested more products than I can count.
I have watched neighbors pour $40, $50, $60 a season into sprays and drenches and treatments that do not work, that have never worked, and that were never designed to work in any permanent way. I have known the answer the whole time. And the answer is chemistry so simple, it fits on a 6th grade periodic table. When you buy that brown bottle at the pharmacy marked 3% hydrogen peroxide, what you are holding is water with one extra oxygen atom attached to the molecule. Regular water is H2O. Hydrogen peroxide is H2O2. That is the entire difference. 2 hydrogen atoms, 2 oxygen atoms instead of 1. One extra atom. And that single atom is the reason the fungicide companies would rather you spend $25 on a bottle of synthetic chemistry than walk to your bathroom and grab something you already own. Here is what that extra atom does.
The moment hydrogen peroxide contacts organic material, the outer membrane of a fungal cell, the soft body of a pest larva, the structure of a harmful bacterium, it releases that oxygen atom in an explosive oxidizing burst. It does not slow down the pathogen. It does not weaken it gradually over several days, the way a systemic chemical treatment claims to. It ruptures the cellular integrity of whatever it touches at the moment of contact. And then, and this is the part that no company with a product on a shelf wants you thinking about too long, it breaks down completely into water and oxygen. Nothing left behind. No residue accumulating in your soil across seasons. No toxic runoff moving into your groundwater. No pre-harvest waiting period before you can eat a tomato from the plant you just treated. Just water and air. Compare that to what you are actually buying at the garden center. The copper-based fungicide you paid $18 for last spring leaves copper ions in your soil, and copper accumulates. Studies from the University of California Agriculture and Natural Resources program have documented copper toxicity in orchard soils after repeated applications over multiple seasons. The synthetic fungicide with the warning label so dense you need reading glasses to get through it carries active ingredients that bind to soil particles and persist. Some of the most commonly sold azole fungicides have half-lives in soil measured in weeks, sometimes months. You are not just treating a sick plant. You are building a chemical history in the ground that every future plant in that bed will grow through. Hydrogen peroxide has no half-life problem. It is not persistent. A University of Florida extension study on soil oxygenation methods confirmed that hydrogen peroxide, applied to growing medium, breaks down to undetectable levels within 24 to 48 hours under normal soil conditions. You are left with nothing but slightly elevated oxygen in the root zone, which, as it turns out, is exactly what roots want. Now I need to tell you about the second thing that happens when this molecule hits soil, because it is the mechanism that explains something every American gardener has seen and never had a good explanation for. Have you ever noticed how your garden absolutely explodes with new growth after a real thunderstorm? Not a light shower, a genuine downpour with lightning cracking across the sky. You probably assumed the plants were just happy about the water. They were not just happy about the water. Atmospheric scientists have known for decades that lightning activity during storms converts oxygen in the upper atmosphere into ozone and peroxide compounds. Those compounds dissolve into rainwater as it falls. The rain that hits your garden after a serious thunderstorm contains measurable trace concentrations of hydrogen peroxide. Your plants evolved over hundreds of millions of years in an environment where periodic peroxide-enhanced rain was a regular natural event. When you add diluted hydrogen peroxide to your watering can, you are not introducing a foreign chemical into your garden. You are replicating a natural process your plants are biologically tuned to respond to. The oxygen released as the peroxide decomposes in the soil reaches the root zone directly. Roots growing in oxygen-rich soil are more metabolically active. They pull in water more efficiently. They absorb nutrients at a higher rate. A healthy root system in well-oxygenated soil produces a fundamentally different plant than the same genetics growing in compacted, oxygen-depleted ground. The difference is not subtle. It is visible within days of treatment. And this matters enormously if you grow in containers, because container soil compacts over time in a way that in-ground garden beds do not. Every watering cycle settles the particles a little tighter. Within a single growing season, the potting mix in a container can lose a significant fraction of its air pore space. That lost space is exactly where oxygen used to live and where roots used to breathe. Hydrogen peroxide drenches restore that oxygen availability without you having to repot the plant, break up the root ball, or replace the medium. You are essentially giving compacted soil a breath of fresh air from the inside out. The industry solution to compacted container soil, by the way, is to sell you a new bag of premium potting mix every season.
At $8 to $14 a bag, multiplied across every container on your porch and in your home, that adds up to a meaningful annual expense. The hydrogen peroxide solution costs you a few cents per application. The math is not complicated. What is complicated is the marketing machinery that makes sure you never do that math. Before we go further into the specific applications and exact protocols, I want to give you one number that puts everything else in context. A systematic review and meta-analysis published in the journal Crop Protection examined 95 separate studies on the effectiveness of peroxygen compounds, including hydrogen peroxide, against fungal plant pathogens. The researchers calculated an overall summary effect score of 3.48 on the Hedges scale, with a confidence level above 99.9%. For context, a Hedges score above 0.8 is considered a large effect in scientific literature. 3.48 is extraordinary. The researchers concluded that peroxygen treatments produced a high reduction in viable pathogen populations across 20 different fungal genera. 20 genera. Not one specific fungus in one specific lab condition. 20 genera of plant pathogens tested across nearly 100 real-world studies, all responding to the chemistry of a compound you can buy for pocket change at any pharmacy in America. That number exists. It has existed in peer-reviewed literature since 2022. Nobody at your local garden center is going to tell you about it. The person in the orange apron is working from a product knowledge script written by the retailers who profit from you buying the bottles on the shelf. The gardening magazines that hit your mailbox every spring are funded by the same agrochemical companies selling you the treatments. The information gap between what science knows and what the retail gardening industry tells American consumers is not an accident. It is a business decision made by people who understand that your ignorance is profitable. That ends today. The first and most important application of hydrogen peroxide in your garden is treating and preventing root rot. And I want to spend real time on this because root rot is the single most misdiagnosed, most misunderstood, and most expensively mistreated problem in American home gardening. Surveys by the National Gardening Association have consistently shown that overwatering and the root damage it causes are among the leading reasons container plants and garden plants die in home settings. Gardeners lose plants every single season to a problem that $1's worth of chemistry could have prevented or reversed. Here is what root rot actually is, because the name makes it sound simple, and the reality is more insidious than most people realize.
Root rot is not caused by water itself. It is caused by what water does to the oxygen content of your soil. When soil stays saturated too long, whether from overwatering, poor drainage, or clay-heavy ground that holds moisture like a saturated sponge, the air pockets between soil particles fill with water, and the oxygen gets displaced. Oxygen levels in the root zone crash, and when oxygen leaves, the anaerobic organisms move in. The primary culprits are 3 fungal pathogens: Phytophthora, Pythium, and Fusarium. These organisms are present in virtually every garden environment in dormant or low population states. They are not waiting for you to make a mistake. They are waiting for conditions to become favorable, and waterlogged, oxygen-depleted soil is exactly the condition they evolved to exploit. Phytophthora alone is responsible for more agricultural and garden plant losses globally than almost any other single pathogen. It wiped out the Irish potato crop in the 1840s.
It destroys avocado orchards in California. It kills tomatoes in backyard gardens from Georgia to Washington state every single summer. Once Phytophthora or Pythium establishes in your root zone, it attacks the root tissue directly. It destroys the epidermis of the root, then penetrates into the cortex, shutting down the root's ability to absorb water and nutrients. The result is a plant that is simultaneously drowning in water and dying of thirst. The roots cannot process the moisture surrounding them. The stems wilt. The leaves yellow and drop. The gardener sees a wilting plant, assumes it needs water, adds more water, and accelerates the exact conditions that are killing it. This cycle repeats until the plant dies, and the gardener concludes they simply have a black thumb. They do not have a black thumb. They have a soil oxygen problem, and no one ever told them how to fix it. Hydrogen peroxide addresses root rot through two simultaneous mechanisms that work together in a way no synthetic fungicide on the market can replicate. The first mechanism is direct pathogen destruction. When a diluted hydrogen peroxide solution reaches the root zone, the free radical oxygen released on contact is lethal to anaerobic organisms. Phytophthora and Pythium cannot tolerate oxidative conditions. Their cellular machinery has no defense against a burst of reactive oxygen. The peroxide does not need to be absorbed into the plant to work. It acts directly in the soil where the pathogens live, oxidizing and destroying their cellular structure on contact. The second mechanism is soil re-aeration. As the peroxide breaks down, it releases molecular oxygen directly into the root zone. Oxygen that was absent, that the waterlogging had driven out, is suddenly present again. The surviving healthy roots, the ones that have not yet been destroyed by the pathogen, immediately begin responding to that oxygen. Root tip activity increases. Metabolic function resumes. The plant starts pulling in water and nutrients again. Gardeners who apply a hydrogen peroxide soil drench to a plant with early to moderate root rot frequently see visible improvement, new upright stem posture, leaves regaining turgor within 2 to 5 days. Not weeks, days. For a routine maintenance drench to prevent root rot before it starts, the mixture is straightforward and worth memorizing. 4 tablespoons of standard 3% hydrogen peroxide, the drugstore bottle, the brown one, per 1 liter of water. Apply it when the top layer of the potting mix has dried out slightly, not to soaking wet soil, and let the medium dry out completely before the next watering. This simple practice, done once or twice a month as part of a normal watering rotation, dramatically reduces the probability of anaerobic conditions ever establishing in your containers or raised beds. For a plant already showing symptoms, already wilting and yellowing with no obvious cause above the ground, the intervention goes deeper and more decisive, and I will walk you through the complete step-by-step rescue protocol in the next section, because it deserves its own undivided attention, and it is the kind of practical information that saves a plant you would otherwise carry to the trash can. Pull the plant out of its pot. Do it now, before it gets worse, because root rot does not pause while you think about it. Set the root ball on a clean surface and look at what you are working with. Healthy roots have a color and texture that is immediately recognizable once you know what to look for. They are white or cream-colored, firm, and slightly springy when you press them between your fingers. They smell like clean soil. Diseased roots look and feel nothing like that. They are brown, gray, or black. They are soft, almost liquid at the worst stages. They collapse between your fingers. And they smell. A sour, swampy, anaerobic odor that tells you immediately that something has been rotting underground while the plant sat in your living room or on your porch looking increasingly desperate. Take a pair of pruning shears and sterilize the blades with undiluted 3% hydrogen peroxide before you make a single cut. Wipe the blade, let it sit for 30 seconds, wipe it dry.
Then begin removing every root that is dark, soft, or showing any sign of decay. Do not be conservative about this. Every compromised root you leave attached is a pathway for the pathogen to continue spreading into the remaining healthy tissue. Cut until you reach clean, white, firm root material.
The plant may look dramatically smaller when you are finished. That is acceptable. A smaller, healthy root system has a future. A larger, partially infected one does not. Once the diseased material is removed, prepare a bath in a clean container. 1 part 3% hydrogen peroxide to 2 parts water. Submerge the trimmed root system in this solution for 5 to 10 minutes. You will see fizzing at the root surface as the peroxide contacts organic material. That reaction is doing exactly what you need it to do. It is oxidizing any remaining pathogen cells on the root surface and driving oxygen into the root tissue itself. After the soak, lift the roots out, gently press them dry with a clean towel, and repot into fresh, sterile, well-draining growing medium. Not the old soil. Never the old soil. The old soil is contaminated, and putting clean roots back into it reverses every single thing you just accomplished. Use a new bag of potting mix with good drainage characteristics. Add perlite if the mix seems dense. The roots need airflow around them going forward. When you water for the first time after repotting, add a mild peroxide drench to the new soil at the 4 tablespoon per liter ratio. This disinfects the fresh medium and gives the recovering root system an immediate oxygen boost. Then practice restraint. Lift the container. If it feels heavy, do not water. If it feels light, water thoroughly and let it drain completely before it sits again. The number one reason root rot comes back after a successful rescue is the same behavior that caused it in the first place. Do not fertilize a plant in recovery. A stressed root system is not capable of processing a nutrient load efficiently, and pushing fertilizer at recovering roots causes salt stress that compounds the damage. Give the plant 2 to 3 weeks to stabilize before you reintroduce any feeding program. Watch for new growth as your signal that the root system has recovered enough to support the plant's above-ground development again. Now let us talk about what is happening on the surface of your plants, because while root rot is the invisible war fought underground, fungal disease above the soil line is the war you can see in real time. And it is where most American gardeners first realize they have a problem, and most American gardeners make their most expensive mistakes. You have seen powdery mildew. If you have ever grown squash, cucumbers, or zucchini in a home garden, you have almost certainly watched that chalky white coating appear on the leaves sometime in mid to late summer. You probably went to the garden center, bought a spray, applied it, and watched the mildew come back within a week. Maybe you bought a different spray. Maybe you tried a third one. Each product promising control, each delivering temporary cosmetic improvement, followed by a return of the infection.
This is not bad luck. This is the designed outcome of a retail model that treats you as a recurring revenue source rather than a problem to be permanently solved. Powdery mildew is a living fungal organism. The white coating you see is a mass of fungal structures growing on the leaf surface. Rust disease, the orange or reddish pustules that appear on rose leaves and bean plants across the country, is a living pathogen. Early blight and late blight on tomatoes, the brown lesions and dark margins spreading across the foliage from the bottom of the plant upward as summer humidity climbs, are active fungal and oomycete infections. Every one of them is alive, and alive things can be killed. A meta-analysis of peroxygen compound research covering 20 fungal genera confirmed effectiveness against botrytis, alternaria, fusarium, phytophthora, and pythium, among others. These are exactly the organisms causing the diseases you are watching destroy your garden.
The oxidizing burst of hydrogen peroxide on contact with their cell walls does not require absorption, does not require systemic distribution through plant tissue. It kills on contact with what it physically touches. For disease prevention before an outbreak begins, the foliar spray mixture is half a cup of 3% hydrogen peroxide per 1 gallon of water. This is your maintenance concentration. mild enough for regular use on most established plants, and effective as a hostile surface environment that discourages fungal spore germination on the leaf tissue. Apply it with a pump sprayer, not a trigger bottle, and take the time to coat the undersides of every leaf thoroughly. Fungal spores colonize the underside of foliage first because that surface is shielded from ultraviolet light and wind. If you only spray the tops of leaves, you are missing the primary zone of infection by a margin wide enough to make the treatment nearly useless.
When an infection is already established, the concentration increases. 8 to 12 tablespoons of 3% hydrogen peroxide per gallon of water. Spray every surface of the affected plant for 3 consecutive days. Then skip one day. Then apply a different preventative treatment, either a baking soda solution, a diluted neem oil spray, or a sulfur-based product to prevent regrowth through a different mechanism. This rotation protocol is critical because it denies the pathogen the ability to develop resistance to any single treatment. No fungus develops resistance to a rotating combination of contact treatments applied in sequence. The pathogen's reproductive cycle is interrupted at every stage. Apply the foliar spray in early morning or late afternoon. Never spray in full sun at midday. Hydrogen peroxide degrades rapidly under ultraviolet light, and if you spray at noon on a bright July day in Texas or Georgia, the active compound will degrade before it has time to work on the pathogens you are targeting. Beyond that, concentrated droplets of any solution sitting on leaf surfaces in direct sunlight can act as magnifying lenses and cause thermal burn on the tissue. Timing the application correctly takes less effort than replacing a plant. 1 patch test before full treatment. Spray 2 or 3 leaves, wait 48 hours, check for bleaching, spotting, or any sign of chemical irritation. This is especially important with orchids, begonias, peace lilies, and plants with thin or delicate leaf tissue. If those test leaves are clean after 2 days, proceed with the full treatment. If you see damage, dilute further and test again. Fungus gnats are one of the most common problems in American container gardening, and they are also one of the most misunderstood. The adult flies, those tiny black insects hovering above your potting soil, are not the actual threat. They are annoying and cosmetically unpleasant, but the adult flies do not feed on plant tissue. The larvae are the problem. Fungus gnat larvae live in the top 1 to 2 inches of moist soil, and they feed on organic matter and on plant roots. In a container with a young seedling or a recently transplanted specimen, a larval infestation can cause wilting, yellowing, and failure to thrive that is visually indistinguishable from root rot symptoms. Gardeners buy yellow sticky traps, catch hundreds of adults, see the problem continue, and conclude that the traps are ineffective. The traps are not ineffective against adults. They are completely irrelevant to the larvae destroying the root system below the soil surface. A hydrogen peroxide soil drench kills fungus gnat larvae directly and breaks the reproductive cycle at the stage that matters.
The ratio is 1 part 3% hydrogen peroxide to 4 parts water. Let the top inch of soil dry out before applying, because dry surface conditions bring the larvae upward toward the oxygen they need. Drench the soil thoroughly and allow it to drain. You will see fizzing at the soil surface where the peroxide contacts organic material and living organisms. That fizzing is the reaction working. Apply this drench every 5 to 7 days for 2 to 3 weeks. Within 1 generation cycle, the adult population collapses because there are no viable larvae developing in the soil to replace the dying adults. Before planting any new season, the soil sterilization protocol is worth every second of effort it takes.
Old potting soil from containers where a plant died, soil from last year's tomato pots, bagged growing medium from an unknown source. All of these can carry dormant fungal spores, insect eggs, harmful nematodes, and bacterial colonies in concentrations sufficient to attack whatever you plant into them. Mix 1 cup of 3% hydrogen peroxide per gallon of water and drench the growing medium completely, ensuring the solution penetrates through the entire volume of soil. Let it sit for 24 to 48 hours before planting. The peroxide will have broken down completely in that window, leaving the medium clean and oxygenated, ready for healthy roots. If you start seeds indoors, and if you have ever had a batch of seeds that swelled and softened in the germination tray but never cracked, never put out a root tip, never became a seedling, pre-soaking in diluted hydrogen peroxide addresses one of the least discussed causes of germination failure. Seeds harvested and packaged commercially carry surface bacteria and mold spores on the seed coat. In the warm, moist environment of a germination tray, those surface organisms can outcompete the embryo before it ever establishes. A 30-minute soak in a solution of 1.5 teaspoons of 3% hydrogen peroxide per cup of water sterilizes the seed coat without harming the embryo inside. Beyond that, the mild oxidizing action softens the hard outer seed coat, accelerating the process that normally happens through moisture cycling and temperature swings in the natural environment. Germination speed on pre-treated seeds improves measurably. For old seeds with notoriously tough coats or seeds past their printed viability date, the improvement can be the difference between a seedling and an empty tray. Every pruning shear you use during disease season is a disease vector unless you treat it as one.
One pass of undiluted 3% hydrogen peroxide across the blade between cuts. 30 seconds of contact time. Wipe dry. That 15-second habit is the difference between a gardener who controls a fungal outbreak and a gardener who spreads it to every healthy plant they touch while trying to manage it. Pots and containers used in previous seasons where root rot or pest infestations occurred should be filled or sprayed with a 1-to-1 solution of 3% peroxide and water, allowed to sit for 10 minutes and rinsed before replanting. The pathogen waiting on the inside wall of that unsterilized pot will still be there in spring if you do not address it in fall or before the new season begins. For those of you growing hydroponically, hydrogen peroxide shifts from useful to essential. Hydroponic reservoirs are warm, nutrient-dense, and recirculating, which creates a near-perfect environment for algae growth, biofilm development, and Pythium root rot.
The standard addition rate to maintain a clean reservoir is 2 to 3 milliliters of 3% hydrogen peroxide per liter of reservoir water, added fresh every 3 to 5 days. Consistent, low-level maintenance is the correct approach, not large periodic doses. And this is a point that cannot be overstated. Never add hydrogen peroxide to a reservoir that also contains a beneficial bacteria inoculant or mycorrhizal product. The peroxide does not distinguish between harmful pathogens and beneficial organisms. Plan your application schedule around that reality. Now let us have an honest conversation, because honest is the only way this channel operates. And there are things about hydrogen peroxide that you need to understand before you use it incorrectly and blame the tool for a mistake in the application. Concentration is everything.
The difference between a beneficial soil drench and a root-burning disaster is the number of tablespoons you put in the container before you add water. Standard 3% hydrogen peroxide from the pharmacy is your baseline for every ratio and every protocol in this video. Do not substitute 35% food-grade hydrogen peroxide without understanding what you are handling. At 35% concentration, hydrogen peroxide is corrosive. It will burn your skin on direct contact. It will scorch roots and leaf tissue immediately if applied without extreme dilution. If you choose to work with 35% concentrate, you must dilute 1 part concentrate with 11 parts distilled water to arrive at a safe 3% equivalent before applying any of the ratios described here. That dilution step is not optional and is not a safety precaution for the overly cautious. Skip it and you will destroy what you are trying to save.
There is a real trade-off when you drench soil with hydrogen peroxide at higher concentrations, and it deserves acknowledgement. Beneficial soil organisms, the mycorrhizal fungi that extend root reach and nutrient access, the beneficial bacteria that cycle nitrogen, the earthworms that create drainage channels and process organic matter. These organisms are also affected by an oxidizing agent in their environment. At the maintenance dilution of 4 tablespoons per liter, the impact on beneficial soil biology is minimal and temporary. At the rescue concentrations used for severe root rot, you are making a deliberate medical decision to accept a side effect in exchange for saving the patient. After a heavy treatment, you support recovery of beneficial biology by top dressing with compost, introducing a mycorrhizal inoculant 2 weeks after treatment, once the peroxide has fully broken down, or applying a compost tea drench in the weeks following. 25 years of growing has taught me that the most expensive garden is not the one where you refuse to buy anything. It is the one where you buy the wrong things repeatedly. The synthetic fungicide at $20 a bottle that you reapply every 2 weeks through the growing season cost you more than $100 annually on a single disease problem. The hydrogen peroxide protocol for the same problem cost you less than $3 for the entire season. That gap in cost does not exist because one product is dramatically more effective than the other. It exists because one product is sold by a company with a marketing budget and distribution contracts, and the other is sitting in your medicine cabinet right now. The practical checklist for the coming season is shorter than you think. Start by oxygenating any container or raised bed that has not been treated in a long time. 4 tablespoons of 3% peroxide per liter of water, applied once to compacted soil, begins restoring air-pore space that has been lost to repeated watering cycles. Pre-soak your seeds this season, every seed, before they go into the germination tray. 30 minutes, 1.5 teaspoons per cup of water. Plant immediately. Track germination rates against any unseeded batch you have from previous years and see the difference yourself. Sterilize every pot before the new season starts. Wipe every pruning blade before every cut during disease season. Keep a labeled spray bottle of the preventative foliar mix ready from the first warm week of spring through the last harvest of fall. The garden industry wants you reactive. It wants you to notice a problem, panic slightly, and reach for a bottle on a shelf. Hydrogen peroxide makes you proactive. It makes the conditions in your soil and on your plants fundamentally hostile to the organisms that would otherwise cost you plants, harvests, and money every single season. You already own the bottle. You already paid for it. Now you know what it actually does. If this video gave you something real, something you are going to use this season, hit the like button right now so that YouTube understands this content is worth putting in front of other gardeners who need it. Leave a comment below and tell me your state or your USDA hardiness zone, because where you are growing changes which of these protocols matter most, and I read every single comment. And if you are not subscribed yet, hit subscribe, because every week this channel puts out information built on one principle. Real gardeners deserve real answers, not a retail script designed to keep them spending money on problems that $1.50 could solve.